All right, I think this is recording. Let's solve this quadratic inequality. Let's always start out with getting the expression, comparing it against 0, then looking to see if we have a greatest common factor, and then after that, why, let's factor it. So I like to work with positive leading coefficients. So I'm going to multiply both sides of this inequality by -1. So I'll have 2x squared minus x minus 15 is less than or equal to 0. All right, so I want to factor this left-hand side, so I'm going to do it with our x method. The middle term is -1x. The first times the last is -30 x squared, and two expressions that multiply together to give me the top, but add together to give me the bottom. And that you just have to play around and do it by trial and error. All right, since the leading coefficient is not 1, I can't come in and use the -6 and +5 directly. Again, I come back to my equation and use the first and the last along one diagonal, and the values that I found in my x along the other diagonal. And it doesn't matter whether I put the -6x here or here. So now I'm going to factor both horizontally and vertically. These share a negative, and they're both divisible by 3. And these are both divisible by 5. This I'll have 2x, and this I'll have x. So this factors to 2x plus 5 and to x minus 3. So the reason that we're factoring this, and we're going to set each of these expressions equal to 0, is so that we can divide the number line into different parts. I'm going to come over here. Let's see. This, hopefully it should be obvious, that if we set 2x plus 5 equal to 0, that you get -5 halves, that if you subtract 5 and divide by 2, and you'll sometimes hear these referred to as critical points. -5 halves is to the left of +3. All right. So this divides our number line into 3 pieces that we'll call A, B, and C. Now, the first decision that we have to make is whether to leave these hollow or shade them in, and that decision is made for us by looking at the inequality to see whether it's a strict inequality or whether it's has an equal to. And this has an equal to, it's underlined, so we're going to shade this in and include this in our solution set. So now we want to decide whether all the points in region A are in or out of our solution set, whether to shade or not to shade. And we're going to proceed in a table, and we're going to pick a test point from each region that will be its representative for the entire region. So if it's true for our test point, it'll be true for every number in the region. If it's false, it'll be false for everyone. So I would suggest that you organize your search in a table. I'm going to create a table with 3 columns. My first column, I'm just going to refer to it as my test point column. My next column, I'll put either the original, or I'm just going to put it in factored form, my inequality. And then my last column, I'm going to call it my truth column. So for region A, I'm going to pick a test point. Now, negative 5 halves is negative 2.5, and a number that's smaller than negative 2.5, I would just pick negative 3. So I'm going to use negative 3 as a test point for region A. I'm going to plug in negative 3 into my expression. 2 times negative 3 is negative 6, and negative 6 plus 1 is a negative 1. Negative 3 minus 3 is a negative 6. And negative times a negative is positive. That 6 is not less than or equal to 0. That's a false statement. So since it's false, I'm not going to shade in any point. I'm not going to accept any point from region A in my solution set. Now, for a test point for B, since we're changing from negative to positive, a nice point to pick is 0 because it's easy to do arithmetic on 0. 2 times 0 is 0. 0 plus 5 is 5. 0 minus 3 is a negative 3. 5 times negative 3 is negative 15, and that's a true statement that negative 15 is less than or equal to 0. So since that's true, we're going to shade in. It's going to be true. It would be true for, there's nothing special about 0. It would be true if we picked any point that was between negative 5 halves and positive 3. Now what about region C? If we pick some number that's greater than 3, say like 4, we've got 2 times 4 is 8. 8 plus 5 is 13. 4 minus 3 is 1. 13 times 1 is 13, but it's a false statement to say that 13 is less than or equal to 0. And since it's false, we're not going to include any of those points in our solution set. So our solution set is just here in the middle, and if we write that as an inequality, we've got negative 5 halves is less than or equal to x, which is less than or equal to 3. And that's my final answer, written as an inequality. All right, well, I hope that helps, and I'll talk to you later. Bye.